Let's find the domain of each of these functions. The first one is a polynomial function, and its domain is all real numbers. So we can write its domain as all of the numbers from negative infinity to positive infinity. The second function is a square root function. The restriction on the domain of a square root function is that the value under the square root has to be 0 or positive. For this function, that means that x minus 2 has to be greater than or equal to 0, or x has to be greater than or equal to 2. If we write that using interval notation, we do want to include the 2 and all the numbers larger than 2, so everything including 2 all the way up to infinity. The third function is a rational function. A rational function has a restriction in that the denominator of the function can never be 0. So we know that the 3x plus 3 cannot be 0, which means the 3x can't be negative 3, or x can't be negative 1. Every other real number is part of the domain, so we can write that using interval notation as real numbers from negative infinity to negative 1, not including the negative 1, union real numbers from negative 1 to positive infinity, not including the negative 1. For the next problem, we're asked to evaluate this function at the value of negative 3. In other words, we'll take negative 3 and substitute it in the function for all the x's that we see in the function. We have to be a little careful if we are substituting a negative value, because we know that there are certain considerations when we simplify expressions that have negative values in them. For example, negative 3 squared means negative 3 times negative 3, or positive 9. In the second term, 9 times negative 3 is negative 27, and then minus 8. 9 minus 27 is negative 18, and negative 18 minus 8 is negative 26. This problem is asking us to evaluate a piecewise function at 3 different values. What we'll have to pay attention to is which interval each of the values is on. For the first one, f of negative 2, we can notice that negative 2 is less than 0. So we'll use the first expression, the 5x plus 3, to evaluate the function at negative 2. So 5 times negative 2 plus 3 is how we'll find the value of the function at negative 2. That's negative 10 plus 3, which is negative 7. For f of 0, we'll notice that 0 is equal to 0. So we can use the second function, because we use that for all values of x that are greater than or equal to 0. So we'll use the 2x plus 7 and substitute the 0 in for the x. 2 times 0 plus 7 is 0 plus 7, which is 7. And finally, for f of 1, 1 is greater than 0, so that falls in the interval for the second defined function, the 2x plus 7. So we'll substitute 1 in place of the x in the 2x plus 7. That gives us 2 times 1 plus 7, or 2 plus 7, which is 9. To find the inverse of this function, we're going to do a slight notational change to make this easier for us. Instead of f of x, we'll say f of x means the same thing as y. So y equals x plus 12 over x minus 3. The next step is going to be to try to solve for x. In other words, rewrite this expression so it says x equals, not y equals. So we'll start by multiplying both sides of the equation by the x minus 3. In that way, we can at least get rid of the fraction in the right side. On the left side, we've got x times y minus 3y, and that equals the x plus 12 we have left on the right side. Now let's move the terms that have x's in them to the left side of the equation. So we'll subtract x from both sides. And then let's move the terms that don't have x's in them to the right side. So we'll add 3y to both sides. So that means we have xy minus x equals 12 plus 3y. Let's factor the x out of the two terms on the left side. So that's x times y minus 1 equals 12 plus 3y. Now we'll divide both sides of the equation by the y minus 1, which gives us x equals 12 plus 3y over y minus 1. Now we have a couple of notational changes to make again in order to write the inverse. The first thing we'll do is change every x to a y and every y to an x. So x becomes y becomes x. That gives us y equals 12 plus 3x over x minus 1. And now our last notational change, we're going to take the y and call it f inverse of x. And that equals the 12 plus 3x over the x minus 1. For this linear equation, the first thing we're asked to do is rewrite the equation in slope-intercept form. So that means we want to write this in y equals mx plus b form. So we're trying to solve for the y. So the first thing we'll do is subtract the x from both sides. So that leaves us with negative 5y minus 7 equals negative x. Now let's add the 7 to both sides. So we'll have negative 5y equals negative x plus 7. And then divide everything on both sides by the negative 5, which leaves us with y equals positive 1/5 x minus 7/5. Part B asks us to name the slope and y-intercept. And since we have the equation in slope-intercept form, that's easy to do. The slope is 1/5, and the y-intercept is negative 7/5. Finally, we're asked to use that slope and y-intercept to graph the function. We'll start with the y-intercept, which is negative 7/5. That's just a little bit below negative 1 on the y-axis. Since the slope is 1/5, we can go up 1 and over 5 from that point to find a second point on the graph. We could continue that again and go up 1 and over 5 and find another point on the graph if we wanted to be really sure that we had points in a straight line. Finally, we can connect the points up with a straight line, and we'll have our graph. Next, we'll write an equation of a line in point-slope form that contains these 2 points. Point-slope form is y minus y sub 1 equals m times x minus x sub 1, where m is the slope of the line, and x sub 1, y sub 1 are the x and y coordinates of a point on the line. Let's start by finding the slope of the line. We have to find the change in the y coordinates and the change in the x coordinates, and then just make a ratio out of those two numbers. One way you can organize that information is to just make a table of the values. So we have a point negative 2, negative 3, and we have a point 2, 7. And we can find the change in the y's. So how far is it from negative 3 to 7? Negative 3 to 7, that would be 7 minus negative 3, which is 10. And then how far is it from negative 2 to 2? Well, that's 2 minus negative 2, which is 4. So our slope is the change in the y's, which was 10, over the change in the x's, which is 4, and we'll go ahead and simplify that to 5/2. To write the equation, we can use either point along with our slope. If we decide we're going to use the first point, the -2, -3, then we would say y minus -3 equals our slope 5/2 times x minus -2. Or if you prefer, we could say y plus 3 equals 5/2 times x plus 2. If we use the other point, the 2, 7, we would say y minus 7 equals 5/2 times x minus 2. These two equations look different, but they represent the same line. To find the distance between 2 points, we're really using the Pythagorean theorem to do that. That's where the distance formula comes from. If you think about these 2 points and where they would be on a graph, we would have the point 2, 3, and we would have the point 7, 8, and we're looking for the distance between them. But we also could think about the right triangle that's formed with that distance being the hypotenuse. If we can find the vertical distance and the horizontal distance, in other words, the 2 legs of the right triangle, we can use that to find the distance between the 2 points, which is the hypotenuse. The vertical distance is the change in the y-coordinates, which is 8 minus 3, so this distance is 5. And the horizontal distance is the difference in the x-coordinates, which is 7 minus 2, so this one's also 5. The Pythagorean theorem tells us that the square of that hypotenuse is equal to the sum of the squares of the other 2 sides. So the square of the hypotenuse is 25 plus 25, or 50. But we want to know what the hypotenuse is because that's the distance between the 2 points. So we need to take the square root of both sides of this equation to find that distance. The square root of 50 is the same thing as the square root of 25 times 2, which is 5 times the square root of 2. So that's the distance between our 2 points. To find the midpoint of a line segment between 2 points, all we have to do is average the x-coordinates and average the y-coordinates. The x-coordinates are 4 and 10. So to average those 2 x-coordinates, we would add them together and divide by 2. And the y-coordinates are 6 and 8. So to average those, we would add them together and divide by 2. So our midpoint is at 14 divided by 2, which is 7. 14 divided by 2, which is 7. So the midpoint is at 7, 7. For this problem, we're going to use translations to graph a function. f of x is on the left side, and we want to graph g of x, which is f of x plus 2 minus 2. So let's figure out what kind of shifts we're going to have to make to the points on the graph on the left side to create our translated graph. First of all, inside the parentheses, you see f of x plus 2. Because 2 is being added to x, that tells us that we have to shift all of our points 2 units to the left. The minus 2 on the end is telling us about vertical shifts. And because it's a -2, we're going to have to shift 2 units down. So every point that we see on the left graph, the graph of f of x, is going to be shifted 2 to the left and 2 down. So let's start with the point -4, 0. -4, 0, if we shift it 2 to the left and 2 down, gets translated to -6, -2. Now let's shift the point -2, -4. If -2, -4 gets shifted 2 to the left and 2 down, it will end up at -4, -6. 0, 0, if we shift it 2 to the left and 2 down, would become -2, -2. 2, 4, if we shift it 2 to the left and 2 down, becomes 0, 2. And finally 4, 0, if we shift it 2 to the left and 2 down, becomes 2, -2. Now all we have to do is connect the dots and we'll get our translated function. Next, we're being asked to write the equation of a circle in standard form with a center at 3, 1 and a radius of the square root of 2. So if a circle has a center at the point AB and it has a radius of r, then the equation of the circle is x minus a squared plus y minus b squared equals r squared. We know that the center of this circle has an x-coordinate of 3 and a y-coordinate of 1 and a radius of the square root of 2. The square root of 2 squared is 2, so that gives us the equation of our circle. X minus 3 quantity squared plus y minus 1 quantity squared equals 2. For this circle, we have to complete the square first before we can find the center and radius and make the graph. So let's start by rearranging some of the terms. We've got an x squared term and a 4x term. We'll put those together. We'll leave a little space. We've got a y squared term and a 6y term. Once again, leave a little space, and then go ahead and subtract 9 from both sides. For the x squared plus 4x, we're going to complete the square. So we'll take the 4 and divide it by 2. 4 divided by 2 is 2. And then square that. 2 squared is 4. So we're going to add 4 to complete the square on the terms with the x's in them. But we have to add 4 to the other side of the equation to keep a balanced equation. And then for the terms with the y's in them, we can complete the square by saying 6 divided by 2 is 3, and 3 squared is 9. So we'll add 9 to the terms with the y's in them, but we also have to add 9 to the right side of the equation to keep a balanced equation. Now that we've completed the square, we can rewrite each of these trinomials as a binomial that's been squared. So x squared plus 4x plus 4 factors into x plus 2 squared. Y squared plus 6y plus 9 factors into y plus 3 squared. And then on the right side, -9 plus 4 plus 9 is 4. So now we can see the center of our circle is at -2, -3, and the radius of the circle is the square root of 4, which is 2. To graph, we'll find the center of the circle at -2, -3. So this is the center. And then since the radius is 2, we can go 2 to the right, 2 down, 2 to the left, and 2 up from there. And that gives us 4 points on our circle, so we can sketch in the circle by connecting those 4 points together. For these two functions, we're being asked whether they are polynomial functions. So the thing to pay attention to is where the x's are in each of the terms. The first equation is a polynomial function. We see that we have an x cubed, we've got an x squared, and we've got an x or an x to the first. So we do have terms that have x raised to powers, and those powers are whole numbers, 0, 1, 2, 3, etc. The second equation is not a polynomial function, and it's because of that last term. In fact, if we rewrote that last term, it would be 4 times x to the negative first power. So when we look at the powers on the x's in each term, we do have an x to the fifth. That's fine for a polynomial. We've got an x to the third. That's fine for a polynomial. However, this term has an x to the negative first in it, and in order for this to be a polynomial, the exponents on the x's have to be only whole numbers. So 0, 1, 2, 3, etc. Negative 1 is not a whole number. The next problem is asking us to sketch the graph of this quadratic function. Quadratic function's graph will be a parabola. And the way this equation is written, we've got a parabola with an equation that's written in what's called vertex form. So we can tell what the vertex of this parabola is by looking at the 4 inside the parentheses. So the x-coordinate of the vertex is negative 4, and the negative 9 outside the parentheses. So the y-coordinate of the vertex is negative 9. Let's go ahead and graph that. Negative 4, negative 9. And because the number multiplying outside these parentheses is an implied 1, which is positive, that tells us that this parabola is going to open up. So that vertex is the lowest point on the graph. We also know that a parabola has a line of symmetry or an axis of symmetry that contains that vertex. So if we think about a vertical line that goes through that vertex, that equation of that vertical line is the equation of our axis of symmetry. So the axis of symmetry has an equation of x equals negative 4. Now let's find intercepts. To find the x-intercept, we're going to set y equal to 0 in our equation. To find the y-intercept, we're going to set x equal to 0 in our equation. So f of x, which is y, equals 0 minus 4 squared minus 9. So y equals 0 minus 4 squared is negative 4. Negative 4 squared is 16. 16 minus 9. So y equals 7. So our y-intercept is at 0, 7. X-intercepts happen where y is 0. So we'll put 0 in for y, in other words, 0 in for f of x. So 0 equals x plus 4 squared minus 9. Add 9 to both sides of that equation. 9 equals x plus 4 squared. We'll use the square root property to solve the equation for x. So plus or minus the square root of 9 equals the square root of x plus 4 squared. So plus or minus 3 equals x plus 4. So x equals plus or minus 3 minus 4. That's two numbers. That's either x equals positive 3 minus 4 or x equals negative 3 minus 4. So we either have negative 1 or negative 7. So we'll go ahead and graph those two x-intercepts, -7 and -1, and then we will sketch the graph of the parabola. Down to the vertex, and then goes back up. It's symmetric, which doesn't look real symmetric with my drawing, but it's just a sketch. Now we're being asked for the zeros of the polynomial function and the multiplicity of each zero, and then graph the polynomial function. So there's a lot going on in this problem. So let's start with the zeros. Zeros are numbers that make the function equal to 0, and since this one's already factored, that's pretty easy to do. First of all, we'll look at the x minus 2, and we know that x minus 2 is equal to 0 when x is 2. And then the other factor we see is x squared minus 1. Might want to factor that. X squared minus 1 is the difference of two squares. So that's x minus 1 times x plus 1. So we also have a 0 at 1, because 1 minus 1 is 0, and another 0 at -1, because -1 plus 1 is 0. Now we found the zeros. It also asked us to name the multiplicity of each 0. So to find the multiplicity, what we're going to pay attention to are the exponents. And what we notice is that the x minus 2 has an exponent of 2. So that means 2 is a 0 with multiplicity 2. It's a 0 twice. The other two numbers, the 1 and the -1, are zeros only once, because we only have one factor of x minus 1 and only one factor of x plus 1. So each of them has a multiplicity of 1. Now let's graph the function. So there's a couple of things that we need to look at in addition to what we found already. Let's go ahead and graph the zeros, because those are the places where our function's going to either touch or cross the x-axis. So we know we have a 0 at 2, we have another one at 1, and we have another one at -1. If we have a 0 with an even multiplicity, that tells us that's a place where our function's going to just touch the x-axis. So at 2, we know there's a touch, and then our graph's going to bounce up and go back the way it came. If we have an odd multiplicity, we know that our function's going to cross the x-axis there. So we have two places where it'll cross, at 1 and at -1. Finally, let's look at end behavior in order to get a sketch of our graph. So what we're going to look at is, first of all, the leading coefficient. That's going to come from the -3. And then we're going to look at our highest exponent on our x terms. We will get an x squared from this x being squared. We'll get another x from the x minus 1, another x from the x plus 1. So x squared times x is x to the 4th. So our highest degree term in this polynomial is a -3x to the 4th. Because the highest exponent is a 4, that tells us that the ends of the graph will go the same direction. They're either both pointing up or both pointing down. Because the leading coefficient is negative, that tells us that our ends are pointing down. So regardless of what the graph does in the middle, we know that on the ends, it's going to be pointing down. So now let's put the information together to make a rough sketch. We know that on the ends, our graph points down. We also know that it has to cross the x-axis at -1. It also crosses at +1. At 2, it touches and then goes back the way it came. So that's a rough sketch of what our graph looks like. Now let's look at some polynomial division. First with long division. We're going to take 6x to the 5th power. And then I don't see a 4th power term, so I'm going to put one in here as a filler. 0x to the 4th, coefficient 0, so we're not changing the polynomial, minus 3x to the 3rd, plus 6x squared, minus 5x, plus 4, and we're dividing that by x minus 2. Okay, let's get the division going. So x times 6x to the 4th is 6x to the 5th. 6x to the 4th times x, that's our 6x to the 5th. 6x to the 4th times negative 2, that's negative 12x to the 4th. Draw a line, change the signs, and add. And that gives us 12x to the 4th. Bring down the negative 3x cubed. And now x times what is 12x to the 4th? That's 12x to the 3rd. 12x to the 3rd times x is 12x to the 4th. 12x to the 3rd times negative 2 is negative 24x to the 3rd. Draw a line, change the signs, and add. Negative 3x to the 3rd plus 24x to the 3rd is 21x to the 3rd. Bring down the next term. That's the 6x squared. And now x times what is 21x to the 3rd? That's 21x squared. 21x squared times x is 21x to the 3rd. 21x squared times negative 2 is negative 42x squared. Draw a line, change the signs, and add. 6 plus 42, that's 48x squared. Bring down the next term, that's negative 5x. And now x times what is 48x squared? That's 48x. 48x times x is 48x squared. 48x times negative 2 is negative 96x. Draw a line, change the signs, and add. Negative 5x plus 96x is positive 91x. Bring down the last term, that's the 4. And x times what is 91x? That's 91. 91 times x is 91x. 91 times negative 2 is negative 182. Draw a line, change the signs, and add. We get a remainder of 186. So our final answer is 6x to the 4th plus 12x to the 3rd plus 21x squared plus 48x plus 91 plus 186 over x minus 2. And now the same problem, but with synthetic division. So this one won't take quite as much writing, but it'll give us the same answer. So we've got 6x to the 5th, no x to the 4ths, minus 3x to the 3rd, plus 6x squared, minus 5x, plus 4, and we're dividing that by x minus 2. So we'll ask ourselves, what makes x minus 2 equal to 0? That's 2. To start, we bring that first number down, bring the 6 down, and now multiply, add. So 6 times 2 is 12. Add 0 plus 12 is 12. Multiply, 2 times 12 is 24. Add, negative 3 plus 24 is 21. Multiply, 2 times 21 is 42. Add, 6 plus 42 is 48. Multiply, 2 times 48 is 96. Add, negative 5 plus 96 is 91. Multiply, 2 times 91 is 182. Add, 4 plus 182 is 186. The 186 is the remainder, and the other numbers are the coefficients of the terms in our quotient. So 91 is our constant term, 48 is our x term, 21 is an x squared term, 12 is coming from an x to the third term, and 6 is an x to the fourth term. So we've got 6 x to the fourth plus 12 x to the third plus 21 x squared plus 48x plus 91 plus our remainder 186 divided by our divisor of x minus 2.